Thank you for joining our webinar. Today, we're pleased to introduce you to our all-new longer-range LiDAR, the mdLiDAR1000LR. I'm Brett Bergdorf, the Marketing Director here at Microdrones, and joining me today is Chuck Dorgan, our Sales Director for the US, and Robert Chrisman, our Marketing Manager and Voice of the Customer. Welcome, gentlemen.
Hey, Brett, thank you for having me.
Yeah, thanks, Brett. Thanks for having us today.
Well, I'm glad you both can participate. We unveiled this new LiDAR product back in July during the official launch of the GE industrial drone line, and it's been very well received. Let me turn things over to you, and you can talk about our all-new LiDAR product.
Thank you, Brett. As most of you already know, Microdrones has joined forces with GE, and I'm happy to announce our first product that we've jointly released, the mdLiDAR1000LR. It comes with a 26 megapixel photogrammetric camera. It's got twice the range and twice the density. This is a groundbreaking product for us. It's going to be a leader in the marketplace. And I wanted to maybe have Robert tell us a little bit more about it in more detail.
Well, thanks for turning things over to me, Chuck. And I agree with you. It's definitely been an exciting year for Microdrones with the release of the HR earlier this year, the announcement of the GE industrial drone line, and now the release of the mdLiDAR1000LR. It's been an exciting 2021. So let's go ahead and move right into the presentation we have here for the LR. What we're going to cover today is the MD4-1000 and the updates to it. We now have the version D that's come out. We're going to talk about the payload and the technical specs that are associated to it. We're going to get into the precision and accuracy, and then also we're going to view some data that's associated to the LR. So jumping right into the new platform, or not necessarily new, but at least updated, the MD4-1000 version D. The first thing you're going to notice is we got the GE decals now with that nice cool blue going on. Another thing that's going to jump out at you is we're back to 2-bladed props instead of the 3. This is mostly just for ease of use in the field. We're still utilizing the robust carbon fiber housing. Still have the GNSS receiver for navigation for both automated and manual flight maneuvers. We're still using the same plus configuration. One of the updates though for the new system is the updated brushless low RPM reliable motors that go along with the new 2-bladed props. We also have remote ID enabled, which helps comply with the unmanned traffic management system and identification requirements that are coming. The flight navigation controller still is reliable for the same stable flight and precise results. Of course, we're still heat and rain resistant. We have another new feature called ground collision avoidance, which we'll get into in just a moment. And then we also have some LED light rings to aid in visibility while the UAV is in the air. The new features to version D, as I mentioned, we had the new brushless motors along with some electronic speed controllers. And through bench testing and flight test, we found that this combination has 10% increased efficiency. We have new LED lights, which provide enhanced visibility when flying. Currently, they're configured as you see here, with the orange light up front and green lights on the other 3 arms. The vehicle is remote ID enabled. Remote identification methods are being implemented for traffic integration and safety. Currently, we're EU compliant and working towards FAA compliance. Ground collision avoidance is another new feature that's utilized during waypoint missions. The dedicated LiDAR unit that's on the front, at 10 meters, if something is detected during a waypoint mission, you get a warning. If something is detected at 5 meters, the mission is actually halted, and then you have to manually fly out of that environment and reprogram your mission. Another update that we have to the version D drone is the RC. We're now up to the MDRC 5.1. This is based on the FreeSky X90 Plus. It has a USB charger. One change on the face of the controller. We used to have 3 buttons down on the right-hand lower corner. Now we have a scroll wheel just for ease of getting through the menus. And another new feature, which I personally like a lot, is the new start-stop button, the big red button that's up there that replaces the toggle switch that we used to use for turning the motors off and on. Some additional minor changes to the version D. We have a new bottom cover that's made out of carbon fiber. We have new landing gear and seating plugs. The batteries now come with integrated locks. The DDL housing has been updated, as well as some cabling and EMC improvements within the body of the drone. And our ground distance control housing has been updated as well. Moving on to the mdLiDAR1000LR payload. LR stands for longer range, and of course the sensor is a Velodyne VLP-32. It's a lightweight time-of-flight LiDAR scanner, which is Class 1 eye safe, has a 90-degree field of view, and one of the new features about this payload that we're excited about is the camera upgrade. We now have a 26 megapixel camera, and combining that with the high point density and increased range, it leads to a lot of area that we can cover with this payload. So let's move on to the technical specs. Of course, we're using the MD4-1000 version D for the platform. Sensor, as we said, is a Velodyne UltraPug VLP32. Camera sensor is Microdrone Zone CMOS APS-C 26 megapixel with a 25mm lens. Of course, georeferencing is handled by the APX15. Software, we're utilizing the MD Cockpit and MD Infinity, as well as the Flight Performance app. Technical specifications, takeoff weight, we're at 6,400 grams. System operating temps, we're at -10 degrees Celsius to 40 degrees Celsius. System accuracy, the LiDAR point cloud, we're at 4 centimeters RMSE, and photogrammetry, we're right there about where the DG payload is also. Continuing on with the technical specs, you can see why we're calling this a longer range payload. The additional range and density by itself is going to lead to a lot more information that's going to be able to be collected. Moving along to the included survey equipment, of course, the MD4-1000 is definitely a part of it. Charger and a rugged carrying case, integrated cooling covers, magless navigation, and of course the LED rings that were mentioned. Communications are handled by encrypted digital data link. The MDRC also utilizes extended communication ranges, multiple tablet control, and of course remote ID is enabled, as we mentioned earlier. The payload is a fully integrated LiDAR scanner, camera, and IMU. Survey equipment software is the MD Cockpit tablet software for planning and flying, as well as a Flight Performance app. And then Tap and Fly is also an option for these vehicles. So taking a look at the payload diagram, there's two main differences that you'll pick up on. One being the LED lights. We now have indicators to let you know what's going on in the payload as it starts up and shuts down. And we also have a debug port in case there's a need to actually plug up to a laptop and debug any sort of issues that may be going on inside. Now let's go over some of the system differences. The mdLiDAR1000HR utilizes the Velodyne Pug VLP16, while the newer mdLiDAR1000LR uses the Velodyne UltraPug VLP32. Both payloads have the same 90-degree field of view. Both payloads have the same LiDAR accuracy of 4 centimeters. Now, one big difference between the two systems, the HR has the 5 megapixel camera and the newer LR has a 26 megapixel camera. But one difference between the two cameras is the field of view. The HR has a field of view that covers the footprint of the LiDAR. The new LR does not. It only has a 50-degree field of view. Let's go ahead and move on to some sample imagery from the new payload. This sample image right here is from 60 meters AGL. On the left-hand side, you can see the full image, and on the right-hand side, you can see 100% crop. Next up is another sample image at 80 meters AGL. Again, the full image is on the left-hand side, and 100% crop is on the right. And we're going to keep on climbing. Now we're at 100 meters AGL. And again, full image on the left-hand side, 100% crop on the right. And I want you to notice how you can still see the cracks in the pavement pretty well at that height. And then one more comparison. The image on the left is from the 1000 HR at 55 meters. And the one on the right is from the LR at 100 meters. So both at 100% crop, and that's a pretty good indicator of the differences between the two cameras. So now we're going to go ahead and jump into the LiDAR side of things. What we're going to look at first is some cut slices from a roof line from the sample data set here. And at 100 meters at 5 meters a second, what we're seeing is about, and this is a 30 centimeter cut slice, we're seeing about 25 centimeters of a noise envelope here. And if we move along at 80 meters, we'll see that that noise envelope comes down a little bit. So now we're at about 20 centimeters as far as the thickness of the noise envelope. And then if we come down a little bit more, now we're at 60 meters, still at that 5 meters a second, you can see that we're getting down even further into about 15 centimeters as far as the noise envelope. Next up, we're going to look at the same data set, but we're going to look at a different area now. We're going to look at some dark asphalt. So again, back at that 100 meters, still at 5 meters a second, we're seeing at about 30 to 35 centimeter thickness of the noise envelope here. And as we move down, again, coming down to 80 meters, still at that 5 meters a second, we're seeing more at about 20 to 25 centimeters as far as the noise thickness of that envelope. And keep on cruising down. We're going to get down here to 60 meters, still at 5 meters a second. And you can see that now we're at about 10 centimeter thickness as far as the noise envelope for the point cloud. And then one more image to look at here. This is a sample, again, 30 centimeters thick of a dirt road, similar site that we were just looking at. And what I want you to see here is what happens after we apply precision enhancement. So the gray dots is more or less after georeferencing, and you can see we have about 15 to 20 centimeters of thickness of the noise envelope. but after precision enhancement, we get it down to about 5 centimeters or less.
Thank you, Robert. I know we've been getting some great feedback on the LR, and at this point, I'd like to remind everyone in the audience that if you're ready to go ahead and purchase an LR, just go ahead and copy down the URL you see on your screen, and with a $2,500 deposit, you can reserve your system today. And then remember, if you decide not to purchase, your deposit is totally refundable. But this way, we can prioritize your order and get the process started so that you'll be able to start processing point clouds with the all-new mdLiDAR1000LR as soon as possible. Okay, Robert, let's dive back in and look a little bit more about what we can use the mdLiDAR1000LR for.
There are many uses of the GE industrial drone line, such as topographic mapping, which is probably the most common use, stockpile volume calculations, monitoring grading work during site balancing, modeling high walls in urban environments, mapping gas lines or other utility corridors, and recreating real-world conditions in a digital format. Moving right along with the idea of what you can expect from the LiDAR, we're going to take a look at a data set here in a moment. This was a site that was collected and then compared to some conventional survey measurements that we have. In the area, we had about 20 traverse points and then about 191 asphalt points to compare to. Overall RMSE for the traverse points was about 14 hundredths of a foot, and overall RMSE for the asphalt was about 9 hundredths of a foot. So you can see we're well within the specs of the LiDAR that we had talked about earlier. So jumping into the point cloud, this was collected, of course, with the mdLiDAR1000LR at 80 meters AGL. I did not use terrain follow with this one. We had 60% overlap and flying at a speed of 4 meters per second. So the density that we have here is pretty impressive. The overall site that we were collecting is more or less the vegetated area you see here in the middle, which right now pretty much looks like just a wooded area. But there's developments going on here that's more or less going to be residential a little bit later. So anyways, let's go ahead and dive into the data here. What I've done is I've gone through and done, of course, georeferencing, precision enhancement, and then colorization as well, and ground classification. So we're going to go ahead and take a look at the classification right quick. So the gray is unclassified. Of course, the brown is the ground. And again, over here in this area that we're concerned with, you can't really see much going on just due to the vegetation. But what we're going to do right quick is turn off the vegetation. Now we can actually see the ground, as well as there was a house that was in there too. So anyway, just to kind of give you an idea of the coverage of what we're able to do within the vegetation. And then another way we could look at this, I'm going to turn the vegetation back on, and we're going to do a quick profile. And then we'll come down here and take a look at that profile right quick. And let's go ahead and pop that up. And here you can see, of course, again, the brown is the ground that's been classified. The gray is the vegetation, everything else above that's not been classified. And of course, the orange in here is the building, as you can see. So anyway, we got really good penetration through the vegetation, it looks like, which should lead to a great model or surface for somebody to use on down the road for the actual design process here. I'm going to take a look at a couple other areas too, as far as some profile views.
Robert, can the LR be used for corridor mapping?
Yes, it can. It is definitely a tool that can be used for corridor mapping. I think one of the things that would lend itself to that is the range of the scanner. A lot of times when you're flying corridors, line of sight becomes an issue just because of the narrow area that you have to fly in. And so getting the drone higher just allows for ease of use as far as being able to keep that line of sight during the flights. So yeah, I would say the LR lends itself well to that application, as well as the data that it collects is definitely within a range of those uses. So again, here's another quick profile. You can see that we got through the vegetation down in these areas. We've got a bit of a ditch line through here. And it looks like a little bit of manual classification could help things out to pick up that bank a little bit better on that side. But as you can see, we have the data for it, which is great. One other area of interest in this point cloud would be the overhead utilities. Let's do a quick profile view of one of these areas. All right, so as it populates here, you can see the lines that are separated. We picked them up really well. We got a couple that get pretty close to each other, and they seem to bleed onto each other a little bit. But as far as utility pole locations, we definitely can pinpoint them, no problem. Connectivity between the poles, no problem. Wire heights definitely looks like something we could pull together with this sensor as well. So anyway, that's pretty much what I wanted to show you in the point cloud. So Chuck, Brett, I guess I'll turn it back over to you so we can move on down the line of things we have to cover today.
Great. Thank you very much, Robert, for going through the point cloud and letting us learn a little bit more about the all-new mdLiDAR1000LR. At this point, Chuck and I are going to talk a little bit about microdrones as a service, which really empowers our customers to deploy the full hardware and software solution together. All right, and this can be done through MD Infinity. And with MD Infinity, we have our various data processing modules, which Robert referred to as he processed that point cloud. These modules are designed so you can easily clean and refine data collected by our drone surveying systems. Let me briefly summarize the modules, and then Chuck will review our updated MD Infinity pricing options for you. So first up is Boresight Calibration, which is used to remove any Boresight bias or minor misalignments within the IMU and the LiDAR scanner. Trajectory Processing merges the GNSS and IMU data and exports a smooth best estimate trajectory, or SBET file, and the exterior orientation files into the needed coordinate system. Georeferencing processes the raw LiDAR data into georeference point clouds. Then strip adjustment can be used to further remove any errors from the data set by correcting any misalignments between the strips. Precision enhancement can be used to reduce the noise levels within the data set while preserving irregular features in the data and removing outliers. With ground classification, it's a LiDAR classification routine that identifies the bare earth within the data set. Direct point cloud colorization is used to colorize the LiDAR point clouds, and then with ForMap, it's used to generate orthomosaics or colorized photogrammetric point clouds. All right, Chuck, let's talk about the selection process a little bit and how microdrones as a service can really benefit our customers when they're ready to purchase or rent drone surveying equipment.
Absolutely, Brett. We've made it simple here. The first step is choosing your integrated system, whether it's going to be the mdLiDAR1000HR or the brand new mdLiDAR1000LR, or maybe even the MD Mapper 1000DG. You select your system, and then the next step would be how are you going to purchase the thing? Are you going to buy it, or are you going to use the hassle-free rent it program through microdrones? Step 3 is going to be, are you going to pay per project or pay as you go? Or do you want to subscribe to an unlimited or a more perpetual type data processing system?
Now, microdrones as a service might not be available in all markets, so be sure to talk to your salesperson for details. But in the short term, we've also made some changes to our pricing structure to make it more flexible for all of our users. Chuck, talk to us about the new processing plans that we now have available.
Yes, exactly, Brett. So we rolled this out in May of 2020, and it was hugely successful. A lot of people are interested in it. Over the past 12, 14 months, we've taken in a lot of feedback from our customers, and some of the feedback was, well, we have something for the light users, we have something for the heavy users, we needed something more in the middle. So we're now offering the Explorer package. Now, what is a medium user? 8 to 10 flights per month, approximately 200 minutes of data collection. But it allows you to not have to worry about you paying for tokens for each one of your flights. We also, within the Explorer package, offer both the basic LiDAR, which is single base trajectory, georeferencing, and 15 gigabytes of storage, of course, on the cloud. With the Pro LiDAR, you also get strip adjustments, precision enhancement. You get the 30 gigabytes of storage on the cloud. So it's more flexibility for our customers. It's more things to offer to our customers. And also, by the way, you can also do 1 month commitment or 12 month. If you do a 12 month, you get better pricing. But if you just want to do it for 1 month and go back to paper project, no problem.
That's great. And I know there's a lot of information on this slide. So probably your best bet is, if you're interested in taking advantage of microdrones as a service, is talk to your sales representative, and they'll do a client needs analysis to help figure out which plan makes the most sense for you to use drone surveying equipment. Now also, if you're doing photogrammetry, we have an Explorer option here as well, Chuck.
That's correct. And the details are very similar. It's still 8 to 10 flights per month, 200 minutes of data collection time. It's really just the basic Explorer package is really the basic mapper, because it's just getting the trajectory processing, but we offer it for photogrammetry as well.
Great. And as you mentioned, if you're not ready for a subscription at this time, you can still continue to do on a pay-per project basis, or if you're working with many payloads or systems, our fleet management options are available as well. So again,
Yep.
Talk to your customer representative, and we'll make sure that you're using the option that makes the most sense. All right, well, it's that time. We've come to the webinar where we want to offer everyone in attendance a special offer. And for this webinar, we have our all-new Explorer special offer. This gives you the opportunity to discover the benefits of processing LiDAR data in MD Infinity at no additional cost, and makes it easy to get started with everything needed to use drones for complex surveying work. Here's what you do. Now through December 15th, 2021, with the purchase of the mdLiDAR1000HR, the mdLiDAR1000LR, or the mdLiDAR3000 through Microdrones as a Service, you'll be able to try the MD Infinity Explorer LiDAR Pro plan for 1 month free. That's a value of $2,420. This special offer includes data processing of 200 minutes of collected data and 560 million points, with complete access to the following MD Infinity data processing modules: trajectory processing, georeferencing, strip adjustment, and precision enhancement. Remember, this offer ends on December 15th, 2021, and the license to be activated upon completion of end user training. To take advantage of this special offer, please contact your Microdrone sales representative for further details, or email mason.styles@microdrones.com. At this point, I'd like to thank everyone for your participation today and attending our webinar, and also special thanks to both Chuck and Robert for their presentations.
Yeah, thank you, Brett. Appreciate it.
Yeah, thanks for having me, Brett. Appreciate it, Chuck.
Great. Should you have any questions that we didn't address, please send them to mason.styles@microdrones.com, and we'll answer those questions shortly after the webinar has concluded. Once again, thank you very much and have a great day.